Hello again, fifth graders. We are going to do Unit 3 review together today. Okay, I'm going to go over 15 problems with you. These 15 problems will be in Think Central for the practice test, and they will be the exact same problems in the math test as well. And though the numbers will change a little bit, the operation and what you're doing in each problem will remain the same, okay? So you can watch this again and again to practice for your math test. Let's take a look at number 1. I'm on page 105 in your Fat Cheetah. I'm doing the review test in your book. But again, like I said, it's going to be the same in Think Central as well. So for number 1, I'm going to look at 1A through D, and I'm going to try not to multiply and use those symbols from the list on the right to indicate if the product will compare, how the product will compare with the factor, okay? So I'm going to use compare symbols. I'm looking at this first term, and I see that this is an improper fraction, so this is greater than a whole number, okay? So I'm taking a whole number and multiplying it by a fraction. Will my answer, x, be greater than or less than these terms? Okay, so the first one. If I have a whole number and I multiply it by a fraction, then my answer will be smaller than the whole number. Okay, so that means the alligator will eat the bigger number. My answer will be smaller than the whole number. However, because I'm multiplying this, I have a whole number, my answer will be greater than the fraction. Okay, the fraction will be smaller, so the alligator will eat the x in this situation. Okay. When I look at 1b, will 4/3, which one will be bigger, okay? All right, 4/3, that's an improper fraction, that's a whole number. So I'm taking a whole number and multiplying it by a whole number. Well, I know when I multiply, I always get a bigger number. So my answer will be bigger in both situations, looking at both terms, because I'm taking two whole numbers and I'm multiplying, okay? Don't let that fraction trick you. It's an improper fraction, it's just more than a whole number. This is definitely a fraction, and this is definitely a fraction. I know if I have a little bit of pizza, and I'm cutting it into even little bit of parts, that number is going to be much smaller. So, when I have my 2/5 and my 1/7, these will both be, the answer will be smaller than both terms. Both terms will be bigger than the x. Oh, I'm writing it a little bit backwards from the way it looks in your book. So let me switch that for you. That's the way it looks in your book. I didn't change the answers, I just flipped it. Let's take a look at this last one. Again, don't let this fraction trick you. 7/7 is just a whole number, that's just 1. So I'm taking a fraction and I'm multiplying it by 1. Well, if I multiply anything by 1, oh, I did it again. X is going to go first. X and 5/8, x and 7/7. So when I take a fraction and I'm multiplying it by a whole number, 1, a whole number 1, that's just going to be equal. It's going to be 5/8 as the answer. Now 1 is, this is just a 1, and if this is 5/8, then 1 is bigger than 5/8, okay? So you can do this whole page without actually multiplying. Just thinking about which one is a whole number and which one is a fraction, or which one is equal to 1, okay? Let's take a look at number 3. We're gonna skip number 2. Let's take a look at number 3. Number 3 says, for the breakfast buffet, Mr. Walker must equally divide 12 loaves of bread between 7 platters, okay? How many loaves of bread are placed on each platter? Write and solve an equation. Okay, if I have 12 loaves of bread, then I must split or divide equally among 7 platters. That's going to be a division problem. I'm going to divide 12 by 7, and it asked for an equation, so I should have a variable. That will be my answer, okay? An equation means I have to equation, I hear the word equal, I have to have an equal sign and a variable. There's my equation. And then I have to have an answer. Okay, I'm just going to solve this problem. First number is the second number is the divisor, and this is the dividend. Okay, so first number dividend, second number divisor. This is how it would be set up in a division box. And 7 goes into 12 once. 7 minus 12 is 5. That is my numerator. That is my denominator. The remainder is the numerator. The divisor is the denominator. And my answer, x, would equal 1 and 5/7. So it looks like 1 and 5/7 of a loaf of bread will be on each platter. Okay, I'm on number 4 now, and I'm on page 106 in your fact cheetah. Erin has 1/3 of an hour to warm up for her gymnastics meet. She must complete each of 6 different stretches. She spends an equal amount of time on each type of stretch, and she does not take a break. How long in hours does she spend on each type of stretch? Write a problem, write and solve an equation. So if I have only 1/3 of an hour, and I have 6 stretches that I need to do in a third of an hour, I'm taking my third of an hour and I'm cutting it up into 6 different spots to see how much time I get per stretch. So here's my equation. 1/3 divided by 6 is going to give me how long I get on each stretch. And now I'm going to think about dividing fractions. I'm going to put, the first thing I'm going to do is make sure both my terms have a numerator and a denominator. And then I'm going to think of keep, change, and I only do this when it's a division problem, okay? Keep, change, and flip, or find the reciprocal. And I have 1/18 when I multiply. So I will get 1/18 of an hour, or Ellen will get 1/18 of an hour for each stretch, since she has 6 stretches. So this is just a division problem. All right. Let's take a look at number 5 now. Ava has 2 frogs. This is 1/3 the number of frogs that Heather has. How many frogs does Heather have? Draw a diagram to represent the division, then write and solve an equation. All right, I have Ava. Ava has 2 frogs. 1 frog, 2 frogs. Those are frogs, okay? I don't know how to draw a frog, so those are frogs. Ava has 2 frogs. And that's only 1/3 of the frogs that Heather has. So Heather, I'm going to go ahead and go like this and cut this into thirds. Heather. Ava only has 1/3 of what Heather has. So if that's what Ava has, that's just 1/3 because I cut it into thirds. If I put 2 in each, it's kind of easy to see how many Heather has. There's my diagram. It also says I have to write and solve an equation. So I took the 2 frogs that Ava had, and I divided them into thirds to see how many Heather has, okay? Now that I'm dividing a fraction, okay, so remember, I took the 2, and then I cut them into thirds. Now I'm going to see how many Heather has. I'm going to first make this both numerator and a denominator. Then I'm going to keep, change, flip, and I get 6/1 or just 6. And that kind of it matches exactly, right? 1, 2, 3, 4, 5, 6. Looks like Ava has 2 frogs and Heather has 6 frogs. And that is 1/3 of, 2 is 1/3 of what Heather has, which is 6. Okay, looking at number 6 now. For a snack, Miss Johnson gives her class graham crackers. She has a package of 20 graham crackers to share equally among 8 students. How many graham crackers should each student receive? Explain how you found your answer. Okay, so I have to explain at the end. Let's first figure out the problem. I have 20 graham crackers, and I have 8 kids. And I'm thinking about the operation I need. Well, if I have 8 kids and 20 graham crackers, I'm probably going to divide the 20 graham crackers by the 8 kids. Okay, so there's my equation. And then I'm going to now solve by just doing division. Remember, the first one is the dividend, and the second term is the divisor. I could do it this way, okay? And I would go 8 goes into 20 twice, that's 16. I get 4 left over. 4 is my numerator, 8 is my denominator, and I know that that's actually a half, okay? I could also go 20 over 1 divided by 8 over 1 and use keep, change, flip. And I see that I have a number that is divisible by both these terms, 20 and 8. I can actually divide both of those by 4. So let me do that. 8 divided by 4 is 2, and 20 divided by 4 is 5. So now I have 5 over 2, and that actually equals 2.5, okay? So you can do it with fractions, or you can do it with division. And then when you explain your answer, okay, so that's number 6. Let's take a look. I have 3/5, and I'm multiplying it by 2/7. Okay, I'm going straight across to multiply. 3 times 2 is 6, and 5 times 7 is 35. That does not seem correct. That's false, okay? Again, I'm multiplying, going straight across. 2 times 5, 10. 9 times 3, 27. Looks good to me. Again, multiplying, going straight across. 7 times 5, 35. 8 times 9, 72. Looks good to me. And the last one, 1 times 3 is 3. 2 times 5 is 10. Uh-oh, that's not right. Okay? So don't let that trick you when you get to your problem. Okay. I'm looking now at number 8. I'm going to have to answer these for number 8. It says that Juan needs to measure 6 cups of flour for a recipe. He only has 1/4 of a measuring cup. How many times must he fill the measuring cup to get 6 cups of flour? This is 1 cup. That's like you can already tell I'm very bad at drawing, okay? That's a 1 measuring cup, but Juan doesn't have that. He only has 1/4 of that, okay? So he's got the little one, 1/4 of a cup, okay? And the question says, how many times do I have to use that 1/4 to get to 6 cups of flour for his recipe? I have to figure out which of these I can use to determine that answer. All right, well, I know for sure, if there's 1/4, there's 4 1/4s in 1 cup, and he's got 6 of those. So if I were to think about that problem, I would say, okay, I think that's a multiply problem. I have 6 cups of flour, and I want to know how many, a division problem. I want to know how many 1/4s are inside of the 6 cups of flour, okay? How many 1/4s are in 6 cups of flour? Well, when I think about this problem and solving it, I'm going to look at this later. When I think about solving this, I would put numerator over denominator and numerator over denominator for both my terms, and then I would keep, change, and flip. Looks like I would get 24, okay? And this would be the same as saying 6 times 4. I hope you can see that in the video. 6 times 4 is 24. Now I'm going to go over here and see which of these match. Did I multiply 6 times 1/4 ever? No. So that one I would say no, okay? Did I multiply 6 times 4 to get 24? I sure did. That one I would say yes. Did I multiply 1 by 4/6? I don't see that there, so no. No. Did I take 6 and divide it by 1/4? Yeah, that's exactly what I had started with. So I would say yes to that. And the last one, did I take 6 and divide it by 4 ever? No. Okay? So that's how I would answer these. I would think about it first, do the math, and then come over here and see which one of these apply. Doing it the other way sometimes is a little more difficult. I'm going to look now at number 9. On number 9, it says Ben has a piece of cord that is 40 feet long, and he wants to cut the cord into pieces to tie up the tomato plants in his garden. How many pieces can be cut if each piece is half a foot long? I have to draw a diagram and then write and solve an equation. So I have to draw something, I have to write something, and then I have to solve, okay? Write an equation, and I have to have an answer. I have to have 3 things here, okay? Let's do the first part. I'm going to draw it. If I have 40 feet, I'm not going to draw 40 feet. I'm going to do 1 foot. There's my 1 foot of cord, and I know that I need half a foot for each tomato plant. For each one. I'll just do a half, okay? I have 40 of those. Okay, so that's how I'm going to draw that. I have, this is my 1 foot, and I have 40 feet. Oh, you're not going to be able to see that. 40 feet, okay? And I multiply that by 40. Now I have my equation. I'm going to take my 40 feet, and I'm going to see how many halves are in 40 feet. So my equation would look like this. And then I would solve. I'd put this over 1. Then I would keep, change, flip, and get 80. So my answer would be 80 pieces that I would get. I'm going to go to number 11 now. Maria plants flowers in a planter that is 1.5 feet long and 1 2/3 feet wide. She plans to cover the entire area with fertilizer. How much area will she need to spread with fertilizer? Area is length times width. It's a multiply problem. I had 1.5 feet long and 1 2/3 wide. So that's actually, I drew this a little longer, so I'll make that my 2/3. There we go. And I'm just going to multiply these 2 problems together. These 2 terms. 1 2/3 times 1.5. I'd make these improper fractions, multiply and add there. So 3 plus 2 more is 5 over 3 times, multiply, that's 2. Add 1 more is 3 over 2. Before I multiply straight across, I see that I have 2 numbers that are both divisible by the same number. It's actually 3. 3 divided by 3 is 1. 3 divided by 3 is 1. So now I just have 5 over 2. And I'm going to say 2 goes into 5 twice. I have 1 left over. Yep. And 2 remains the denominator. So 2.5 feet is what, square feet is what she will need for number 11. Okay, let's take a look at number 12. For number 12, of the coins in Simone's collection, 13 25ths are quarters. Of these quarters, 2/3 are state quarters. What fraction of Simone's coins are state quarters? So she's got 13 25ths are quarters, and of those quarters, what does of mean? It means multiply. I hope you said multiply. Of means multiply. 2/3 are state quarters. I'm going to multiply that by 2/3. Okay? I'm going to look. I don't see any numbers that I can cross cancel or reduce. So I'm going to multiply straight across. I'm going to get 26 over 75. And that's my answer. Don't get confused with that of. Of means multiply. Okay, we are going to skip 13. We're also going to skip number 14. Those aren't going to be on the test, but these three will be. So let's take a look. I'm trying to use my comparing and compare. I'm looking at 4/5. I have two fractions. When you multiply two fractions, you're taking something small and cutting it up by even something smaller. So your term is very small, okay? Your answer is going to be very small. So 4/5 will be bigger. Oh, let me do color. Let's see. 4/5 will be bigger than what the answer is. This is saying, what will this answer be? This term, 4/5 will be bigger. I'm looking here. This is a whole number. It's an improper. It's a mixed, an improper fraction, which would be a mixed number, but it's a whole number in there. So a whole number times a fraction will get you the fraction. Your answer will be bigger than the fractional part. So that answer will be bigger because I have that whole number. Here, I have one whole. So this is basically saying 1 times 3/8. Well, that's going to equal 3/8. Okay? All right. Let's take a look at number 18. In number 18, I'm going to put these letters A, B, C, D, E, and F into these different categories. It's either going to be less than 2/3, equal to 2/3, or greater than 2/3. Take a look. 2/3 is the common term in each one, okay? So now again, you're thinking about your fractions, you're thinking about whole numbers, you're thinking about things that equal 1. If I take a fraction and I multiply it by a fraction, my answer is smaller than both of these terms. So it's going to be less than, A, less than, okay? I'm not gonna multiply to find that out. I know that I have two fractions, that's gonna be less than. That's a fraction, but that's a improper fraction. So that's a mixed number, so that's a whole number in there. So I have a fraction and a whole number. Well, now my answer will be greater than the fraction. So B will go here. Now I'm looking here. 9/9, don't let it trick you, that's a 1. 2/3 times 1 is 2/3. That's equal. C would go here. Here, I see that they made it into a fraction, but 6/1 is just 6. 2/3 times a whole number means I will get an answer that's greater than 2/3. So my D will go here. Again, fraction and fraction. When I have two fractions, the answer will always be small, because I have something small and I'm cutting it up even smaller. So E will go here. And F, I have a fraction and a whole number, that will be greater. So F will go here. Okay. My last problem, number 19. I have Hannah and she wants to divide 5 oranges equally among 4 children. So I'm taking 5 and I'm dividing it by 4 children, okay? Here's the model that she drew. The question wants me to explain, it wants me to know if Hannah's model is correct first, and then explain your reasoning using words, numbers, and pictures. So I'm gonna say yes or no, this model is correct or not correct because, and then I'm gonna explain. So I'm gonna take a look at the model first. I have 5 oranges, looks right, divided into 4s, cut into 4s. So far that looks right. Now, bear with me, it's gonna get a little messy here, but she took each orange slice and gave it to the 4 kids. So she took this one and went there, one went there, one went there, and this last one went there, okay? Here we go. Now we're doing this orange. This orange one went there, this orange one went there, this orange one went there, this orange one went all the way over there. So far everybody's getting 1, right? Now we're going to this orange. This orange cut up to that plate right there. This slice right there. This slice right there. This slice over here. Okay, we still have 2 more oranges left. I know it looks crazy. Keep going. We got this one. This orange slice is gonna go all the way over to this plate. This orange slice is going over here, right there. We got this orange slice that will go right there. We got this last orange slice will go right there, okay? And then my last one, okay, this orange slice will, oh, there it is, traveling all the way there. This orange slice all the way there. This orange slice right there. And this last orange slice there. I know this looks insane, but yes, her model is correct. This model is correct because each of the 5 oranges was divided into 4. Or I guess I would say fourths. Was divided into 4ths. So each child gets, and let's see, how much does each child get? Well, if I put this orange together, there's 4 slices in an orange, right? So I've got 5. Looks like they get 4 slices. 1, 2, 3, 4, 5 slices. So it's 1, and out of this second whole one, it's a 4th. Get 1 and a 4th orange. Okay. So yes, and then an explanation about why that's correct. All right. Now why don't you try Think Central, Unit 3 practice test.